3.3 Problem Solving with Combinations. When building subsets of a given set, you can choose from 0 to n elements to be in the subset. The total number of subsets of a set of n elements is the following. That means given that each element of a set could be either included or excluded, which can be counted as two different ways. Since there are n elements, this could be done in 2 to the n ways. The total number of subsets of a set of n elements is 2 to the n. Null sets have 0 elements. If a null set is excluded from the tally, the total number of subsets would be 2 to the n minus 1. So, we're going to look at examples that involve this. Next part. Consider using the indirect method, especially if it involves fewer cases, such as when you need to choose at least 1 or 2 items. If the order is important, consider selecting the items first, then arranging them in order. So this is in the sense that if there is some sort of order, then consider selecting the items first and arranging them in order. So it's kind of like a combination of combinations and permutations. And we're going to see an example here dealing with this as well. So example number 1. A bag contains 8 different colored marbles. Use 2 methods to determine the number of ways to reach into the bag and pull out 1 or more marbles. Here we go. Let's look. Method 1. We can take, we have 8 marbles in the bag, we choose 1. Or we can take 8 marbles, choose 2. Or 8 choose 3, and so on. All the way through up to and including 8 choose 8. Because remember it says 1 or more marbles. So I can choose 1 all the way up to all 8 marbles, like a handful. So, how do we know what value that is? You can type that in your calculator and you get 255. That means there are 255 ways that marbles can be pulled out of a bag. Now, let's look at method number 2. How's another way that we could do this problem doing it in a different way? Well, that is if we consider the indirect method. So, since you must reach for at least 1 marble, the ways will be 2 to the 8 minus 1, which is basically the null set. So the value of 2 to the 8 indicates that each of the 8 marbles has the possibility of being selected in 2 ways. Now, either picked or not picked, chosen or not chosen. Now, the 1 represents the number of ways with no marbles chosen. So again, what we're looking at is the null set. That null set, 8 choose nothing, is not an option here. But if we want to add 2 to the 8 includes that option, so we have to subtract 1. 8 choose nothing, we're subtracting that. And by doing that, we're left with 255. So it's kind of neat how we can use that indirect method to get our answer. All right, next piece. Example 2. In the game of hearts, the entire deck of cards is dealt. If you have a hand with 13 cards, in how many ways could the hand contain at least 2 hearts? So, we want to have at least 2 hearts up to the maximum number of hearts in the set of cards we have. So there are 13 hearts in a deck of cards. There are 13 cards in our hand, so we can have the maximum of 13 hearts. So, there are 52 cards altogether. Our hand can be 2 hearts and 11 cards, or 3 hearts and 10 cards, or 4 hearts and 9 cards, or 5 hearts and 8 cards, or 6 hearts and 7 cards, or just a minute, or 7 hearts or 6 cards, 8 hearts and 5 cards, or 9 hearts and 4 cards, or 10 hearts and 3 cards, 11 hearts and 2 cards, or 12 hearts and 1 card, or 13 hearts and 0 cards. Now, these are the possible hands you could have in your hand with the 13 cards that you have. So, let's convert that to combinations. Well, we could have 13, from the 13 hearts that are in the deck of cards, we're going to choose 2. Times the remaining number of cards that are not hearts is 39. And we're going to choose the remaining cards, 11, from that deck of 39 without the hearts. Now, when we write the word or, what we do is we add. We add the next possible combination, which is 13 hearts, choose 3, times 39 of the rest of the cards, choose 10. And so on. So we're going to continue this. So 13 choose 3 times 39 choose 10 plus, and this one we're on now, 13 choose 4 plus times 39 choose 9 plus 13 choose 5 times 39 choose 8 plus 13 choose 6 times 39 choose 7 plus 13 choose 7 times 39 choose 6 plus 13 choose 8 times 39 choose 13 choose 8 times 39 choose 5 plus 13 choose 9 times 39 choose 4 plus 13 choose 10 times 39 choose 3 plus 13 choose 11 times 39 choose 2 plus 13 choose 12 times 39 choose 1 plus 13 choose 13 times 39 choose 0. Now, looking all of this, imagine typing this into your calculator. That's right, this is way too long and very hard not to make calculation errors. And usually you'll make your error somewhere around here and you have to go back and type it up. Folks, that doesn't make any sense. So there's got to be a better way. And you know that there is. Let's erase all this and figure out a better way to get the answer here. That is, using the indirect method. The indirect method says there are 52 cards totally in the deck. We have 13 that we're going to choose. And we're going to subtract what we can't for sure get. That is, 13 choose 0. That means no hearts whatsoever because we need at least 2 hearts. So 0 hearts is not a possibility. So we subtract that. So that is 13 choose 0 times 39 choose 13. Next, we subtract. So 0 hearts, and when it means at least 2 hearts, we also subtract the 1 heart possibility. 13 choose 1 times 39 choose 12. Okay, folks? So what we have here, this way is a much faster way to get the answer that we're looking for. And that's exactly what I need you to do, is to take out that answer, okay? And we get the answer when we plug this in, and I guarantee you would get the same answer. Now we're going to talk about this number here. All right. When you type this into your calculator, I'm pretty sure most of you are not getting this exact number here. And we're going to talk about how to get this exact number because, again, we're looking at numbers, such fine-tuned numbers, that it's important for you to understand how to get the number you're looking for, the exact value. Now, hint, if your calculator gave an answer like this one that you see here, You see, when I did all of this information, I did 5.7 times 10 to the power of 11. Some of you have an e to the 11. What this means, and what you're going to have to do, is do some creative math. That is, you take the answer that you have in your calculator right here, and you're going to subtract. Now, I'm noticing that some calculators are giving me different answers. So I'm going to basically, most calculators are giving me the right answer if you subtract 5.7605 right from the question. Right from the question, if you subtract that, okay, what's going to happen is you're going to get the answer that you're looking for. So we'll just look at this for just a second. So we subtract 5.7605. So 4 decimal places, exactly what it says on the screen here. So I'm just going to take exactly what's here, folks. 5.7605. So go to the 4th number after the decimal, and we're going to times that by 10 to the 11. 10 to the 11, meaning that what we're looking at here is we want to go 10 to the 11, which is the same number that's here on the calculator. And we subtract that. And what that will give us is it will eliminate this part of the entire thing. So the answer in the calculator will be 767,488. Why is that important? Well, you see the numbers here. 5 matches with 7, 6, 0, 5, 0, 7, 6, and 7. Are those numbers here. It's all of these numbers here. The next number it says is a 5 on the calculator screen, but reality is the next number is a 488. By subtracting this first piece of the number, what your calculator will give you is the remaining part of the number, because these numbers are exact. There are no decimals. And by subtracting that, what you'll end up having is you'll be able to find the remaining numbers in the number that you're looking for. Because I'm going to tell you right now, this scientific notation is not exact. I am going to be looking for numbers that you can actually find exactly in your calculator. And this is a way you can eliminate the scientific notation. All right, moving forwards. Part B, finding the ways to have at least 10 hearts. Well, at least 10 hearts means you need to have 10 hearts, 11 hearts, 12 hearts, or 13. If it's 10 hearts, it's 13 choose 10, times 39 choose 3. 11 is 13 choose 11, times 39 choose 2. 12 means 13 choose 12, times 39 choose 1. And 13 is 13 choose 13, times 39 choose 0. What you end up having values are these, if you type them into your calculator. And the total possibilities is equal to the addition of all of these values here, which is 2,672,060 possibilities. Now, in this case, you don't want to use the indirect method because it's much easier just to find the direct and adding them all together. Another example. What happens if you're asked just to find 5 clubs and 5 spades? Notice I say 5 clubs and 5 spades. Well, 5 clubs and 5 spades means we have, this is what we're looking for, 5 clubs and 5 spades. So that means that we're looking at 13 choose 5 for the clubs, times 13 choose 5 for the spades, and the remaining cards, there are 26 cards remaining, and we will choose 3. We want exactly 5 clubs and 5 spades. Moving on to the next part. Well, this value is these numbers again, and folks, you'll probably have to do a little bit of that subtracting with the scientific notation. Part D, 3 diamonds. If you want exactly 3 diamonds, means that you want to get 13 choose 3 and 39 choose 10. To give you the value, again, you're playing with the calculator with this. And E, 5 clubs or 5 spades. Now be careful, because of the word or, it changes things up. Basically what you're looking for is 5 clubs or 5 spades means 13, choose 5, times 39, choose 8, plus 13, choose 5, times 39, choose 8. Why is that the case? Because of the word or, either we're having 5 clubs or 5 spades. We can't say 26, choose 10, because in honesty, the 10 could end up being all clubs or all spades, not exactly 5 clubs or 5 spades. Finally, your answer is here. And folks, again, you have to be able to work with that scientific notation. If you need some help, come in and see me. All right, one more. Example number 3. How many 5-letter codes can be formed from 2 different vowels and 3 different consonants? Consider Y a vowel. Let's look at the possibilities here, folks. Well, the code has 6 vowels, and we need to choose 2, times 20 consonants, and choose 3. Now, this is the specific what I need. I need 2 vowels and 3 consonants. Now, the thing is, they need to be in a certain order, because again, this is a code. So one letter, then the next letter, then the next letter, and the next letter. What that means is we take the product of 5 factorial. That means we're taking that permutation that we did in the previous unit, and we're combining it with the combination. So we want it in a specific order. And that's earlier on in the lesson I talked about how you have to calculate the combination first and then apply the order that they appear in. Alright, and then you can calculate this value into your calculator, folks, to get the value. Alright, and that's the end of the video. You have a numerical day. Take care, folks. Oh, before I forget, here's your answer, folks. 2,052,000. That's how many different codes can be combined with the 2 different vowels and 3 different consonants. Alright, folks, now take care. Have a good night.